Math 1314, Tyler Junior College, Other Types of Equations, Section 1.6. In the previous video, we introduced rational exponent equations, and we came up with a technique for solving them, along with an annoying caveat. Here's what we talked about. To raise something to a rational exponent, the numerator dictates the power on the base, whereas the denominator dictates the index. So x to the m over n power can be viewed one of two ways. The nth root of x to the m power, or the nth power of the nth root of x. In other words, you can do the exponent first, or you can do the radical first. And we solved one particular rational exponent equation, it's not this one, by raising both sides to the reciprocal power. But there was an annoying little caveat. When solving x to a fractional power equals k, and the numerator is even, we used a plus minus in our solutions. Must we do that here? Let's find out. This is almost the same equation as before. In the previous video, we solved x to the 2/3 power equals 64. In this one, we're going to solve x to the 3/2 power equals 64. So how are we going to solve that? Well, the same way we did this. We're going to raise both sides of the equation to the reciprocal power. So let's get ready. What is the reciprocal of 3 over 2? 2 over 3. And remember, the reason that works is we have set up consecutive powers on the left, and there's an exponent rule that says when you raise a power to another power, they get to multiply. Because these are reciprocals, their product is 1, so this simplifies to x to the first power, which is just x. Now, as far as 64 to the 2/3 power, the 3 means a cube root, so we'll do a cube root of 64. The 2 means a second power. We can either put it on the 64 inside the radical or outside the radical after we do the cube root. I opt for the second. So what is the cube root of 64? Well, let's think about it. A little thought cloud here. To answer the cube root of 64, we need to answer what times itself 3 times is 64. Well, a little guessing and checking will reveal that 4 to the 3rd power is 64. And so the cube root of 64 is 4, but then we have to square it, and we get x equals 16. But just, let's check our answer. To check the answer, we have to substitute 16 back into the original equation and see if it gives us 64. So 16 to the 3/2 power equals 64. Excuse me, we don't know that yet. We're checking that. To raise 16 to the 3/2 power means to set up the square root of 16 and then raise that answer to the 3rd power. The square root of 16 is 4. And 4 to the 3rd power, as we've already established, is 64. So yes, 16 is a solution. But is it the only solution? In the previous video, we discovered that negative 16 was also a solution. Would negative 16 be a solution here? Well, think about it. What would happen if I put a negative here? I'd square root it and get an imaginary number. Will that work? Well, that's equivalent to asking, is there another way to get 64 here? Because that's what really stemmed the discussion last time. I believe last time the scenario was we had something squared equals 64. In the original version, we were checking it had 8, but then we said, wait a minute, won't negative 8 also work there? Backtracked and figured out that we needed a plus minus on our original solution. Would that possibly work here? If I put a negative on this 4, will it give me 64? When I cube it, negative times negative is positive, but times a 3rd negative turns it negative again. So, no. A negative 4 here wouldn't work. So I don't need to worry about this 4 being anything else besides a 4, which means I don't have to worry about this 16 being anything else besides a 16. So just for completion, when solving x to the m over n power equals k, comma, and m is odd, don't use plus minus. If the numerator is odd, then when we use the reciprocal power, we are cube rooting both sides. Cube rooting does not invoke a plus minus, and in general, odd roots do not invoke a plus minus. Only even roots do. And the root we take of both sides ends up being the denominator of the reciprocal, which is the numerator of the original. Let's take a look at one more. I don't want to mislead you into thinking that all rational exponent equations look like this. They come in quite a few varieties. For example, you might have one where you have to isolate first. For example, let's say I ask you to solve 5x to the 3/4 power plus 1 is equal to, let's say, I don't know, I'm just making stuff up here, not 9, let's put something, it'll be 16, we'll use that. Well, I'm still going to hit it with the reciprocal power when the time is right, but like most equation solving strategies, or like many equation solving strategies, your first move should be to isolate something. In this case, we need to isolate the part with the rational exponent because that's what we want to hit with the reciprocal power. That's pretty easy. Subtract 1 from both sides. Get 5x to the 3/4 power is equal to 15. We're not done isolating the part with the rational exponent, so let's divide both sides by 5 and get x to the 3/4 power is equal to 3. Now, before we do anything else, let's decide if we need a plus minus. That is dictated by the numerator and whether it's odd or even. The numerator of the rational exponent is 3, that's odd, and when it's odd, we don't use a plus minus. So at this point, and we could have decided that at the beginning, because this is odd, there is no plus minus. So let's proceed. To eliminate the rational exponent, raise both sides to the reciprocal power. So we're going to raise both sides of this equation to the 4/3 power, The product on the exponents on the left side is 1, so we just get x to the 1st. And over here we have 3 to the 4/3 power. Good luck evaluating that. I know the 3 means I do a cube root, and the 4 means I do a 4th power. Let's put the 4 inside for a second. Actually, let's not. What is the cube root of 3? Hint, it's not 1. 1 times 1 times 1 is 1. The cube root of 3, and most cube roots, is irrational, meaning is a decimal that goes forever and never repeats. So we're not going to evaluate it. Does this mean that we're done? Well, I guess you could say it. Well, if we were done there, are we done here? I guess you could say that also. But I can't think of at least one thing we can do. If we can't do the radical, can we do the power? How can we do it second? Oh, wait a minute, we can do it first. We can sneak the power inside, and we can do 3 to the 4th power. 3 times 3 times 3 times 3. That's just arithmetic, and it's equal to 81. So it's debatable which of these answers is better. 3 to the 4/3 power, the cube root of 3 raised to the 4th power, or the cube root of 81. If this were a question on a online homework system, it should dictate to you how it wants its answer. Something eating away at me. There's an even better answer than all of these. I don't think an online homework system would expect you to do the following, but we can simplify this because we can split this into 2 cube roots, one of which we know the cube root of. Now normally we do this with square roots, but it's actually something you can do with any radical. If I break the 81 down into 27 times 3, which does equal 81, I happen to know the cube root of 27. What multiplies 3 times in a row to get 27? 3. And if you really want to have a minor brain explosion, there was a real quick way to get here from this. What I'm about to show you is not usually shown in most textbooks or most teachers. Simplifying radicals like this is a little cumbersome because you have to make the perfect split and then locate a perfect cube in this case. But if my plan was to do that, I could have started with 3 to the 4/3 power. Why? Well, isn't 4/3 an improper fraction? It is. Can I write 4/3 as 1 1/3? I can. And isn't there an exponent rule that says when you multiply matching bases with, let me write it down. Isn't there an exponent rule that says x to the a times x to the b equals x to the a plus b? There is. But any rule you can do forward, you can do backwards. If I think of this 1 1/3 as 1 plus 1/3, then I can disassemble it into 3 to the first power and 3 to the 1/3 power. 3 to the first power is 3, and 3 to the 1/3 power, according to this rule, is the cube root of 3. It's a sneaky way to simplify a radical by using rational exponents. If your rational exponent is an improper fraction, it has a whole number part, that will tell you what goes outside the radical, and then the remaining fraction tells you what goes inside. Sneaky, I know.